Sir?
Nope, I just forgot to press the record button.
Oh, okay. We'll go on then. First, before I get into the details of an actual penetration test, I'll make a very quick plug for regular vulnerability scanning. Qualys is a centrally funded tool that's available to UW-Madison departments at no direct cost. While it does not have the depth of a penetration test, it can find a lot of vulnerabilities with minimal effort. Penetration testing and vulnerability scanning complement each other. They are far more effective when used together. That's just a plug. Getting on to the real nuts and bolts of penetration testing, it starts with meetings. Meeting with the system owners, discuss what will be tested and how it will be tested. In those meetings, 3 documents are created and signed before any ethical hacking takes place. The scope document defines what is to be tested. The rules of engagement define how it is to be tested. And the permission memo is what officially and legally authorizes penetration testers to attack a system within the limitations of the scope and rules of engagement. Once these documents are signed, we move. The recon phase fundamentally looks at publicly available information using tools that are very familiar to everyone on the internet. Penetration testers use Google. They look at a website. If the scope includes public-facing websites, the testers will look at them, particularly for web forms and other places where user input is taken, because an improperly configured web form is a major location for weaknesses. Opportunity for an attacker if it isn't set up right. We will also use Shodan. I'll show you that a couple slides later. But first, many people don't realize how easy it is to see the source code on a public-facing website. In Chrome, it's just a matter of pointing at the dots on the upper right corner, selecting more tools and then developer tools. This isn't a hack. This is just seeing what is publicly available in a different format. When I was learning about web design, I did this in a variety of sites to see how code is used. But in penetration testing at the beginning of a test, vulnerable code can be found that way, particularly if there's a web form. We can see what's going to the server and in what format, and that can be a clue where to look for vulnerabilities. This is a really good page. I wouldn't bring this up publicly if there were weaknesses visible here. But not every page I've seen is this good. Likewise, I wanted to show you a Shodan page because Shodan is often misunderstood or seen as a hacking tool. Fundamentally, Shodan is a search engine. In terms of underlying technology, not unlike Google, Bing, or any other search engine, except that it focuses on hardware and software and other technologies rather than the content of a web page. No question, hackers use Shodan. It can identify vulnerable systems, but systems administrators and security teams also run Shodan on their own spaces so they can see what's visible to the public that perhaps shouldn't be. This particular example, again, it's showing because it is what a systems administrator would want to see. This is a public-facing web server. We've got Apache running, ports 80 and ports 443, which are essential to web services, are open and no other ports. And the services, the host names are all limited to what is necessary for the website to function. If I were a website administrator, this is what I would want Shodan to show. But as a member of the security team, not every Shodan page I see is this good. We find a lot of the time we find ports open and non-essential services running. Mapping follows reconnaissance. The theory is no different from mapping a building or a city, except that we deal with the logical topology, the logical layout, as well as the physical locations. By logical topology, I mean LANs, local area networks, and VLANs, which are virtual local area networks. In many places, the logical topology will be different from the physical topology. Simplest example being if there's a cubicle building where two different departments are working in the same physical space, they will be organized in two different VLANs, even though they're close together. To segment the network and to keep people, to create a logical separation that minimizes the scope of breaches and also maximizes the efficiency of a number of network protocols that we don't have time to go into right now. Mapping is usually automated for speed and reliability, but as we move further into the test, it becomes more manual. Once the tester knows the layout, they begin looking for weaknesses that a criminal could exploit. Typically, this will be done through a process called fingerprinting, where we will either monitor traffic if we're already have some access inside, or traffic that's going out from the network if we're still outside. That can give us clues. Sometimes active fingerprinting will send specially crafted information, communication to a server or another service, and the exact format of what is returned will reveal the operating system or other software that's running. We also scan for open ports at this stage. All of this provides clues to the underlying structure, not a whole picture. At this stage, the ethical hacker is not logged in with credentials, so they don't see everything, but they see enough, usually to know what is most vulnerable and to get ready for the exploitation phase. Now, the map, before I go on to showing some of the most common exploits, I will stress that mapping and discovery phases are very different for an ethical hacker than for a criminal. The criminal is just trying to get in. Once they've found an exploitable weakness, they will usually launch their attack, do whatever crime they intend to commit, and then exit as soon as possible to avoid leaving evidence, unless they decide to backdoor the system for future access. The ethical hacker is trying to help security. Therefore, their goal is to find, ideally, all major vulnerabilities, but at least as comprehensive a picture as resources and time constraints allow, and document what needs to be fixed. That means the mapping and discovery phases are much more comprehensive, much broader, and take more time than an actual attack. We'll look at a couple of the exploits here. The most common are injection attacks, typically against a database. Malice in the middle, sometimes we call it machine in the middle now. Buffer overflows, shell code. I'll show this in a couple more slides here. Injection attacks, basically this is used when there's a web form or some other type of user input. The attacker will typically know something about the back-end code at this point, not a complete picture, but enough to know that something is vulnerable or at least strongly suspected. And then they will use code or code snippets where the program expects text or a numeric value. And this can alter the logic of a SQL query. The simplest injection is or 1 equals 1. Because 1 equals 1 obviously is always true. And the or means that when this is injected into a SQL query, the query will return true for every record in the table. A web form that's meant to only reveal the user's individual data will, if this injection succeeds, reveal the entire table. Most modern systems will detect and block an injection this simple, but it is a way to see how it works. JavaScript and even shellcode can be injected in certain highly vulnerable systems. Injection, there's a lot of variations on how it's done. Machine in the middle or meddler in the middle attacks are very different because they are attacks against the network. What happens here is the attacker tricks the user's computer into thinking the attacker is the router. This is done through corrupting what is called the ARP cache. ARP means address resolution protocol. If the attacker manages to corrupt users' ARP settings, they will send data to the hacker that's meant for the internet. The hacker, to avoid revealing their presence, will forward it to the router. Then it goes out to the internet, and whatever return traffic the user expects will also come in through the attacker. This monitoring can reveal a lot of information, sometimes just through metadata, can provide a lot of clues as to underlying systems, help fingerprint systems that they might not have identified yet. Ethical hacking is an iterative process. There will be gaps in the initial discovery phase that are often filled later, particularly when the attacker is in the middle like this. Also, and particularly scary from the defender's perspective, is the attacker can break weak or misconfigured encryption, and that's a real wake-up call for the security team. If they thought their data was secure because it was encrypted, and the penetration tester breaks an outdated encryption algorithm, that is quite a warning. But that's the opportunity to make it stronger before an actual criminal would do the same thing. Buffer overflow is a little harder to understand because that's looking at an area of the computer, a level of functionality that is not, most of us never interact with directly. But what happens here, you have one function creating another function, or calling another function is properly called. And when that happens, the function creates a structure in memory called a stack. This is a very simplified illustration of a function stack. We're only looking at what is relevant. But there's data passed to the function, which is stored in an area called the buffer. That's why we call it a buffer overflow. Then a very important value called the return pointer, which is a numeric value indicating a location in memory. And this allows this function to return to the function that called it after it's done executing. Below that, there's the function code and a number of other values and information that's omitted here for clarity. Now, if an attacker sends more data to the function than the function expects, and there isn't a protective measure like a bounce check in place, the attacker can overwrite the return pointer with a different memory address. So when the function finishes, instead of going back to where it was called from, control is redirected to a shellcode or another form of malware that the attacker wants to execute. Shellcode, when I say shellcode, I don't always mean a command window, but usually that's what happens. That's what comes up when shellcode executes successfully. When a command window is up, that's when the attacker, whether an ethical hacker or a criminal, can execute arbitrary commands. Not always with administrative or root privileges, but once a skilled hacker gets a command prompt like this, the chance is very high that they will find a way to get administrative privileges, even if they don't have it when they first open the window. There are quite a few exploits. We don't have time to go into them in detail, but there are quite a few exploits that allow privilege escalation. Most of the time, getting into a reasonably well-designed modern system requires an attack chain. This is just an example. The process is iterative, and the details will differ with every target system. But the discovery tool will find a vulnerable application. There will be an exploit that allows access and gains shellcode execution. This example refers to a buffer overflow. Privilege escalation may require a separate exploit, and only then will a criminal be able to do what they set out to do. And in the case of a penetration test, the testers will be able to document that the system is vulnerable and point out what needs to be fixed. Like I said, the most important part of a penetration test is the report. This is what gives system owners and their IT teams the information they need to harden the system, to patch vulnerabilities, to prevent a criminal from achieving the same level of access that the penetration tester did. This is what gives a penetration test its value. That's the most important result of what we do. Now we're getting a little low on time here, but I'm going to enumerate some of the most common testing strategies. The most common ways penetration testing technology and teams are used. Network tests, that will test firewalls, configuration of network devices. We'll also look at things like internal divisions, internal segmentation. If a person can too easily move laterally once they've gained access, will show up in a network test. They may also look at VPN, consider the security of data in motion, if that's in scope. Always the scope. A penetration tester is only authorized to access what is included in the scope document. Web application tests will look at both the front end, which we saw a little bit when I showed you the code, but that's only the front end. We will test the back end through injection attempts, and vulnerability scans. We will also consider the server and database security. Automated tools are pretty useful, but they do not do everything that a hands-on penetration tester can find. External tests starts from outside the network, and that, in the majority of cases, most closely mimics what an adversary would do, because they will be outside the network initially and have to find a way in. It's in some ways the most involved type of penetration test, but also the most realistic. Finds the gaps in the perimeter security and then finds out once inside what can be accessed and follow up. Internal tests work entirely inside the network, often focusing on specific high-value areas or types of technology that are defined in scope. In some cases, the developers or operations IT staff may observe the test, talk to the tester about what is vulnerable and how the actual hack operates. When this is done, the proximity between the penetration tester, sometimes called the red team, and the defender, sometimes called the blue team, leads to a term a lot of people have heard, and that's purple teaming. Assume breach is a specific kind of internal penetration test. Again, an adversary emulation or simulated attack. that starts with the attacker already having access. Avoid spending time and effort getting in, and demonstrating or investigating is the better way to describe it, what a hacker could do if they do get in. The reason assumed breach is a good strategy is on a network as large as UW-Madison, sooner or later an adversary will get in. That's reality. Knowing what an adversary can do, how other systems are in place to detect an adversary is very important, and that's why this strategy is often used. Ultimately, effective penetration testing makes a network more secure. Nobody wants to be hacked. Even when the network security team or a system admin sees an ethical hacker got in, it can be frustrating to see how your defenses didn't work. But the purpose is so that the defenses can be strengthened, networks hardened, vulnerabilities patched, and the entire IT infrastructure made more secure so that criminals are denied an opportunity. That's the reason for ethical hacking. Tim, do we have any questions?
Well, no questions have shown up in the chat as of yet, so I invite the participants, audience here to if you have any questions, feel free to pop open your mic and ask away.
It's a small group here, so don't be shy.
Well, I guess I'll get things kicked off here. So when either a hacker or ethical hacker or a criminal wants to gain access and get user credentials, what are some kind of common ways that that person may get credentials for users to then elevate through the network?
There's a number of ways that's done. Sometimes they will be able to access the password hash. That's called a pass the hash attack. More often, they will intercept the hash in something like a man in the middle attack, or machine in the middle is the proper term, and then put it into what's called a rainbow table or a hash table. And that is the hashes of thousands and thousands, sometimes millions of passwords. The program will compare the hash that they've intercepted to the hash of known passwords. And when they get a match, they have the password. That's the most common way it's done.
Okay. Looks like a couple questions here in chat. Laurel's asking, who conducts pen tests? Is mostly outside groups or internal groups, and what are the pros and cons of each?
Internal, obviously, is using UW-Madison's own resources in the Office of Cybersecurity. People I work with in testing and cyber defense specifically are very skilled ethical hackers. And it keeps the whole process in-house and minimizes cost. On the other hand, like I said early in the presentation, there's limited resources in terms of personnel and time. Tests have to be scheduled, they have to be prioritized. And that means that, practically speaking, some people will get penetration tests done from outside vendors. They have more resources, it can be expensive. And as I said before, please let security know. We oftentimes detect an attack and don't realize that it's an authorized pen test unless you let us know.
All right. Another question from Brian here. When you refer to a network as large as UW has, What network do you mean? WIS.edu or others? He thinks of UW as many networks, not just one big one.
That was a deliberate oversimplification there. UW-Madison, and particularly the UW system, if we're considering that, is hundreds of networks and subnets and network segments. It's not simple. To explain penetration testing, I kept the idea of the network as simple as possible. Typically, a penetration test will be authorized by a department such as a school or similar, and it will be authorized on their network or networks. That would be what a network, that would be where the term network would typically be applied in penetration testing.
Well,
obviously, one thing that would be a concern would be if there's an opportunity for a hacker to move laterally between networks that might be in the same building, if the routers are not properly secured. But in most cases, there would merely be recognition that that possibility exists because the other department would not be in scope. And therefore, there would be absolutely no targeting it.
all right. Well, we are at 4 o'clock. Julie, I appreciate you coming and presenting this afternoon. And thanks for everyone to as well for participating and being in with us. Hopefully we'll see you tomorrow at our coffee hour tomorrow morning, and then starting off with IT awards tomorrow morning. So thanks everyone. Have a good evening, and we'll see you guys soon.
Have a good evening.